Welcome students. In this class we will write a C++ program to find the roots of a quadratic equation. Now on the screen you can see this is the formula that we will be using. Now this b squared negative 4ac, this is often referred to as the discriminant, and based on the values produced by the discriminant the roots would be characterized. And let me just show you the characterization. So have it in mind that b squared negative 4ac is called the discriminant, and it is usually represented by small d, capital D, or by delta. So based on the values that is extracted or produced by the discriminant, the roots are characterized. So as I mentioned to you, depending on the value of d, the nature of the roots will be actually characterized. So if d is equal to 0, the roots are equal and real. So in fact the best way to say is the roots are real first and then they would be equal. And similarly, if d is greater than 0, the roots will be real and they are distinct. So in this case the best way to put it is the roots will be real and equal. So that is the way to say that, or that is the way to term them. Then as I mentioned to you, if d is greater than 0, the roots will be real and distinct, and in this case if d is less than 0, the roots will be imaginary. So the best way to say that would be the roots will be complex. So these are the characterizations. So having mentioned this characterization and shown you the formula, let me head on to write the code. So I would comment this off. So first we need to include our IO stream, and then I would include math.h. we need to perform some calculations, and then using namespace std, it's the library, then we'll start with int main, and then we'll have to declare the roots. See, when a quadratic equation is given, the form of the quadratic equation would be as follows. So let me just show that to you. The form would be ax squared. I'm trying to write this. So you have ax squared positive bx and positive c. This is the form of a quadratic equation, and that will be equated to 0. Now a, b and c, this is the input that the user will have to give. Okay, this is from the user. So we will have to get the value of a, b and c, and from then onwards we will have to calculate the discriminant, make the judgment, and then obtain the roots. So every quadratic equation will have two roots, so have that in mind. So having mentioned that, let us go back to the code and get the value a, b, c. They will have roots, root 1 and root 2. Now if it is complex, we are not going to calculate them. Okay, so having mentioned that, let me give c out. Okay, this is the app for calculating the roots of a quadratic equation. So that is fine. So having given that heading, let me give underline to it so that it looks a little bit attractive. Okay, so now let's get the input. So C out, please enter the coefficient of A. Okay, so from here the coefficient of A is obtained, A is got. So I will copy this up and then I will paste it here. So this is going to be, please enter the coefficient of B and this is going to be b, and the coefficient of c, that's fine. Okay, so now we have to calculate the discriminant. So I will also declare it as such, discriminant. That's the spelling for discriminant, and that is declared as a variable. So over here the discriminant is calculated, b squared, b into b minus 4 times a into c. So that is the value for the discriminant. Now we have to make the conditional check. So if the discriminant is equal to 0, so first we will have to check the equal to 0. Okay, then you type C out, the roots are real and equal. Okay, and we give end L. Now we have to calculate the roots. So how do we calculate? R1 is equal to negative b, so it's going to be within parenthesis negative b plus the discriminant plus the discriminant divided by 2 times a. This is the first root, and we can copy this and give the second root. Okay, in fact in this case we don't even have to include the discriminant because the discriminant is already 0, right? So I will take this off, so we don't need to have a discriminant. The only thing is that the sign, one would be negative b and the other will also be negative b, because R1 and R2 will be same here. So in this case what we can do is we can calculate just R1 and take out this. So when we are printing this, we will say it like this: C out, the roots are R1, and then you place twice within parenthesis. So that's the understanding. That root is basically occurring 2 times. Okay, and I will also give else. Okay, you can simply say C out, the roots are not equal, just for the time being, right? Because I just want to show you the output. So that's fine. So I save it and I end it. This will be okay. So please, this is the app. Please enter the coefficient of A is 1, coefficient of B is 4, coefficient of C is 4. You see that I told you the roots are real and equal, the roots are negative 2 twice. X plus 2 times x plus 2, because x is equal to minus 2 is a root, but x plus 2 is a factor. So we will have to multiply the factor. So when we multiply the factor, we would get x squared positive 4x positive 4. So that's about it. So that's fine. So this works, and if condition is there, so we will have to give in one more condition. So if this is case, then you act like this. So I don't need to have placed this, so I will just take this off. So if this condition fails, we will have to give another else. So in this case I will just incorporate as else if discriminant, else if discriminant is greater than 0. Okay, if it is greater than 0, then what you got to do, so this is the else if block. So foremost we will have to calculate, or I should say first we will give the display. We will say the roots are real and unequal. So that is fine. And now we will have to calculate the roots. So R1 is equal to negative B plus SQ RT. We need to use the square root function and calculate the discriminant. Okay, so close it and close it, and you divide by 2 times A. So that is how we calculate the root. Now probably what you can do is you can just simply copy this and paste it, change R1 to R2 and positive to negative, right? So it's going to be negative B plus or minus. So this would handle the 2 roots. So we can give the roots. So the first root equals R1 and NL, and then you can also give the second root. The second root is going to be R2. Now if this fails, right, so this is the block, this completes the else if. If this fails, then you'll have to say C out, the roots are complex, right? So that would be sufficient for the program. And we have to also give a return 0. So let me just close this here and give return 0, and then finally the closing parenthesis. So this looks fine. Probably I will reduce a few of the asterisks. So I save it and I run it. So please enter the coefficient. Let me just enter the coefficient. I want to give x squared negative 18x positive 45, and the roots should be 15 and 3. So coefficient of x squared is 1, coefficient of b is negative 18, the coefficient of c is 45, and the roots are 15 and 3. That's correct. Okay. So if you want, you can try one more question. I want to run again, and now I'm going to give the system as x squared negative 3x negative 10. So the roots for this I know is negative 2 and 5. So let's check it out. So coefficient of x squared is 1. Coefficient of b is negative 3, and the coefficient of c is negative 10. Negative 10. So as I mentioned to you, the roots should be negative 2 and 5. You see that? Negative 2 and 5. So this is a lovely program, and we have extensively placed in all the required conditions. So you can work on this and you can see for yourself how the roots are literally obtained, and this will work for any form of quadratic equation, so you wouldn't have to worry. So finally I want to give a complex equation. Okay, let me show that to you also. So if I were to give, I know this is a complex quadratic equation. Complex in the sense it produces complex roots. It is x squared positive x positive 12. So the coefficient of a is 1, coefficient of b is 1, the constant term coefficient of c is positive 12. So the roots are complex. You see that? Roots are complex. So that is the end of this program, students. Thank you.